Welcome to the May 2019 edition of the AJP Heart and Circulatory Physiology video table of contents, or from the editor's desk. Spring is in the air, and we have some great cardiovascular science, including reviews, perspectives, and original research. This issue is filled with novel studies, so let's take a quick tour. In our first review, Stecklings and co-authors discuss the physiological and pathological role of several important peptides and enzymes that regulate and affect the renin-angiotensin system. These include Ang2, Ang17, allotensins, and alamandine, the AT1 and AT2 receptors, and the MAS receptor, as well as ACE and ACE2. This review provides a quick overview of this system and brings us up to date on the recent developments in the field, as well as potential for new therapies. In a second review relating to the renin-angiotensin system by Escobales et al., they discuss the intracellular renin-angiotensin system, notably the intracellular renin-angiotensin system in neurons, fibroblasts, renal cells, and cardiomyocytes, particularly in mitochondria and in the nucleus. The stimulation of nuclear angiotensin II receptors enhances mitochondrial biogenesis through peroxisome proliferator activated receptor gamma coactivated 1, alpha, and increases sirtuin activity, thus protecting the cell against oxidative stress. Recent studies in Ang2-induced preconditioning suggest that plasma membrane AT2 receptors stimulation exert protective effects against cardiac ischemia reperfusion by modulating mitochondrial AT1 and AT2 receptor signaling. Zhuang et al. Investigated the fatty acid binding protein 3, or FABP3, a low molecular weight protein which participates in lipid transportation, storage, signaling transduction, oxidation, and transcriptional regulation. They evaluated the expression and function of FABP3 in ischemic heart disease and explored the mechanisms by which FABP3 affected remodeling after myocardial infarction. They show that ischemic or hypoxic conditions upregulated FABP3 expression in vivo and in vitro. Notably, overexpression of FABP3 induced more myocyte apoptosis in the infarction and border areas and aggravated cardiac dysfunction with lower left ventricular ejection fraction. This study demonstrates that deficiency of FABP3 protects cardiac myocytes from apoptosis and alleviates cardiac remodeling after MI, suggesting FABP3 as a potential target to preserve cardiac function after MI. Et al. Hypothesized that local mesenchymal stem cells delivered via a novel bioscaffold can improve right ventricular function despite persistent pulmonary artery hypertension. They induced PAH in adult rats with SU5416 and chronic hypoxia exposure, treated with rat mesenchymal stem cells delivered by intravenous injection, intramyocardial injection, or epicardial placement of a bioscaffold, and then examined treatment effectiveness by in vivo pressure volume measurements, including echocardiography, histology, and immunohistochemistry. They show that compared with other treatment groups, only the MSC-seeded bioscaffold group resulted in RV functional improvement, including restored stroke volume, cardiac output, and improved stroke work. Cardiac myocyte hypertrophy and RV fibrosis were both reduced. In a novel methodology paper, Sled et al. Established a method to measure reflected waves in the human umbilical artery and assess their influence on blood velocity pulsation. 95 pregnant women were recruited between 26 and 37 weeks of gestation and examined by Doppler ultrasound. With the use of a computational procedure, a pair of forward and reverse propagating waves were identified to explain the variation in observed Doppler ultrasound waveforms along the cord. Among the data sets that met data quality requirements, waveforms in 93 of the 130 arteries examined agreed with the wave reflection model. Strong reflections were associated with large differences in pulsatility between the fetal and placental ends of the cord. As reflections arise from transitions in the biomechanical properties of the blood vessels, these observations provide a plausible mechanism for the link between abnormal waveforms and clinically significant placental pathology and could lead to more precise screening methods for detecting pregnancies complicated by placental disease. Thank you for watching this overview of the May issue. I urge you to go to our website and view all the great papers published this month. We hope to see new authors and old at upcoming conferences, including the Council on Basic Cardiovascular Science of the American Heart Association and the AHA scientific sessions in the fall. We'll keep reminding you of these upcoming events. Have a great month, and we'll see you again in June.